A situation that occurs pretty often in science and in life is that we want to measure things that we can't actually measure. Often the things that we want to measure are actually only expressed indirectly through the measurements that we are able to make. The true governing variables or states are not visible. They are under the surface or behind the curtain. Instead, we have to measure proxy data and use the proxy data to infer the unseen states. This is sort of a fundamental principle for unsupervised learning. The things that we are looking for, be they labels or relationships, are things that we were not able to measure directly. If we had those things, then we wouldn't need to do unsupervised learning. It's also, to some extent, true of supervised learning. Even though we are handed labels in the case of supervised learning, the way that those labels actually relate to the unseen, hidden structure of the data is what we have to unpick through the learning process. The principle of hidden variables or hidden state is implicit in, for example, principal components analysis, where the dimensions that we are constructing, the more true dimensions of variability, are representing some kind of hidden reality that is indirectly captured by the dimensions that we actually measure. And in clustering, we are pretty explicit about the fact that we are measuring some kind of hidden state. The cluster memberships are unseen, the cluster centroids are unseen, but we're attempting to infer them from the data that we have available. In this week's topics, the latent variables are made more explicit still. We are explicitly imposing that kind of structure on the data. We are defining what the hidden variables are, what they represent, and how they relate to each other, and also to the observations that we can make. So for the purposes of these discussions, we will be considering only hidden state, so something that defines what state the system is in and that affects the outputs that we observe. But it's worth noting that another way that latent variables can arise is if our measurements are in some way incomplete. So if we have missing data values, if there are things from our series of measurements that we accidentally failed to measure, or that the relevant things were not available at the time or whatever. So one way of dealing with those problems is to treat the missing data as extant but invisible, and then do the fitting that way. The general processes involved in both of these are basically the same, although in practice the hidden state version can be easier to understand and express and apply, because the hidden state structure is more well defined.